I will come to section 2, which will immediately give you a top level overview of 4 parameters which play important role. I have already talked about this: torque, speed, power. Remember, torque into speed is power, and energy. Energy is power integrated over time. At different speed it will be moving. So, it can also be power and speed integrated in a certain manner. This is the drive, and we will do an introduction here. More detail we will do when we do the chapter 2, vehicle dynamics. So, whether it is IC engine, petrol or diesel engine, or motor, it will generate certain torque and rotation at certain revolutions per minute, RPM. Speed is measured for a motor or for an engine in terms of revolutions per minute, RPM. So, the units are also very important. You need to understand these units because you will be using these units again and again. Controller will control torque and RPM. So, not the full only power. Controller will therefore say, okay, I want so much, my power is so much, I want so much torque, so resulting RPM, or I want so much RPM, so my torque will be given. I can of course increase, decrease power. So, in some sense I have independent control of torque and RPM. So, vehicle torque is measured in terms of Newton meter. Newton meter. We will get into more details of this Newton meter. Is force multiplied by the radius of the tire. That is a torque. Force multiplied by the radius of the tire. This vehicle torque will come from motor or engine. Our tire is the radius of the tire in meters. We are just going to use meters and units like this. Force will be newtons. So, Newton meter is force into radius of tires. Force is in terms of Newton, R is in terms of meters. So, force into R tire is the torque. Now, what is the purpose of the torque? Torque's purpose is 4 folds. First fold, there will be when you try to drive the vehicle and the wheels are rotating, the road, depending on the road roughness, will try to slow down the tire rotation, and that is called rolling resistance. So, you need to overcome. If you add force, so that tires keep on rotating at that speed. If you do not, then the vehicle will slow down. So, the first thing that the torque has to do is overcome the rolling resistance, and we will get into details of rolling resistance. The second thing that it has to worry about is, as you are driving at a certain speed, you are actually hitting against the air, you are pushing the air away. That is called aerodynamic resistance. The air, I am not talking about wind, I am just talking about air that is there, even if it is stationary, even if there is no wind. It does not like vehicle passing the wind. So, it has to, that is called aerodynamic resistance, that will slow down that. So, you have to apply a certain force to overcome that aerodynamic resistance, and we will be able to compute the aerodynamic resistance. And third, we may want to accelerate. So, we want to accelerate, that is a pickup of the vehicle, that is the third force. So, the torque will be used to overcome these 3, plus if you are driving up the hill, it has to also overcome the gradient resistance. Of course, if you are driving down the hill, you get helped. Instead of gradient resistance, and gradient is helping you. So, to that extent less force will be required. Similarly, if you are decelerating instead of accelerating, the deceleration will help you, you require less force. But rolling resistance and aerodynamic resistance you will have to always overcome. Both will depend on the kind of road, kind of tire, rolling resistance, and the speed at which you are running. The aerodynamic resistance will depend on the shape of your vehicle, how much wind it is displacing, and the speed at which you are going. You will find higher the speed you go, aerodynamic resistance will keep on increasing like anything. We will learn each of this, but basically vehicle torque is required to overcome them, and remember that is force into the radius. The next important parameter is vehicle speed and power. Speed is almost always measured in MKS unit as a kilometer per hour, defined by motor engine revolutions per minute. So, from revolutions per minute you should be able to calculate kilometer per hour. That is an important relationship. So, speed is given in terms of meter per second or kilometer per hour. Now, meter to kilometer per hour is you just divide by 3.6. Why? Meter will become a kilometer if you divide by 1000. Second will become an hour if you divide by 3600. So, take that. So, kilometer per hour divided by 3.6. So, if you have 36 kilometer per hour, you divide by 3.6, you get 10 meter per second. So, speed in kilometer per hour divided by 3.6 and you get 10 meter per second. Suppose you are driving at 72 kilometer per hour, you divide by 3.6 and you will get 20 meters per second. So, that is the relationship. Now, this kilometer per hour or meter per second is revolutions per minute multiplied by tire radius in meter multiplied by 2 pi by 60. Why 2 pi by 60? Because 2 pi r is the circumference. So, one revolution you will travel 2 pi r. Why divide by 60? Because you are taking revolution per minute and you want it everything in second. So, if you take tire radius in meter multiplied by RPM multiplied by 2 pi by 60, that will give you speed in meter per second. Now, you can calculate 2 pi by 60 is 9.55, close to 10. So, very often people sort of say you multiply RPM with your radius of the tire in meters and just divide by close to 10, 9.55, then you get the meter per second. And now, if you calculate speed in kilometer per hour is what? 3.6 times speed in meter per second. So, that is RPM multiplied by R tire by 9.55. So, this is the way you can calculate speed. It is a very simple high school arithmetic. Please learn that, this is important. We will get into more details later on, but all the time sometime you will talk about kilometer per hour, sometime you will talk about meter per second. Sometime you will talk about RPM and tire radius. You must be able to very quickly convert that, not get confused, do not make mistakes in this. Now, this was the speed. What about power? Power is force into velocity, and force you normally put in newtons and velocity is in meters per second. Now, what is force? Force is torque divided by radius. Torque is Newton meter, radius is in meter. So, torque divided by radius, and velocity we have just seen is RPM into R tire meter per second divided by 9.55. So, if you multiply this, R tire gets cancelled. Power does not depend on the radius of the tire, it is torque into RPM divided by 9.55. Torque in newtons is simply power in watts is simply torque multiplied by RPM divided by 9.55. So, these two simple expressions, remember that, always use that, do not confuse between the units. Now, a very, very important concept, gears. What does gear do? You have a certain torque, you want more torque, use gear to increase the torque. So, if IC engine or a EV motor may give less torque than a vehicle require. You increase the torque by a gear. A gear can multiply the torque by what? By n times, where n is the gear ratio. So, the n times you can multiply, because torque by ensuring the gear ratio is n. So, vehicle torque can be n multiplied by engine or motor torque, not engine by motor, engine or motor torque. Engine torque when I am talking about IC engine, motor torque when I am talking electric vehicle. So, gear will multiply torque, but remember power is same. So, what will happen? It will multiply torque, it will divide RPM at the expense of RPM. Gear multiplies torque and divides the RPM. So, vehicle RPM will be reduced by n. So, vehicle RPM will be engine or motor RPM divided by n. This should be engine or motor RPM, not engine by motor. Engine or motor will make this change, engine or motor RPM divided by tau n. Of course, so therefore, you can multiply torque, reduce RPM. You can do vice versa also. Vehicle power is therefore same as engine power or motor power. You cannot create power. Whatever is the motor power will be the vehicle power. You can have higher speed torque, lower speed, or lower torque and higher speed. Thus, engine motor torque may be multiplied at the expense of RPM or vice versa. A must for IC engine. Electric vehicle is an option. Why? Electric motors, at least motors in future, you will be able to generate wide range of torque and wide range of RPM for the same power. If you have limit in terms of the range, then you may require a gear. Normally a fixed gear is required, but multiple gears are not required. In a IC engine, you have a smaller range of torque and RPM, and therefore, you want to increase torque, you go into a higher gear, So, if you drive for example on gear 1, you get very high torque, that is what you do in the beginning. Then you come to 2, you get a little less torque, you can go higher speed. Go to 3, now you can go higher speed, torque is less. Go to gear 4, you can go, normally that is the way you do in vehicle. So, you have 4-stage gear. Electric vehicle, you can do that, but the newer motor, tomorrow's motor, we like to design which can give me high torque or low torque at every power. So, I can increase or decrease the speed. This is possible in motors. You can use gears with motors. In the beginning, you may use. Tomorrow, you will get more flexible motors. Remember that when you design those kind of motors, you will eliminate gear. That will be very, very helpful. It will make the whole vehicle more robust, but it will be a little more expensive motor and controller. And you will also learn that you will need a certain voltage. Remember, a drive train has a certain voltage. If you do not start with certain voltage, it will be difficult to get the good range of torque and speed. For example, I have seen 48 volt very often is used for e-rickshaw and autos. If you use 48 volt for autos, you can't go from lowest speed to highest speed and highest torque to lowest torque, very difficult. If you go higher voltage, that is not a problem, and this is something that we will learn in due course. So, this is the question, do you use a multi-gear or a changeable gear? That is what we use in IC engine all the time. Gear 1, gear 2, gear 3, gear 4. Multi-gear or changeable gear can change gear ratio. It can be 1:4, 1:8, then it can become 1:2, 1:1. It can even become reverse. Gears change using a clutch. So, you normally use a clutch to disengage the gear then you change the gear. So, essentially you have multiple wheels, you will use a clutch to disengage and then change the gear. So, temporarily disengage from motor. This is how ICE engine has always been designed, always with gear, changeable gear, clutch and gears. You are doing a little bit of that in electric vehicle, you are doing less and less, and at some point of time even eliminate that. EV motors usually designed to work efficiently with large range of speed or torques and can use fixed gears. Of course, not all motors to begin with, but over time you can go do this. That would be the preference as long as one can meet all the vehicle requirement with the motor and a fixed gear. Now, fixed gear will mean much more robustness, won't fail easily, cost will go down, but your motor and controller has to have that. And one thing that I learned over time, you probably will need to have a certain drivetrain voltage and then have the current change of the right kind to be able to get the range. At low voltage it may be difficult to do that. You can do that, but things become very complex, cost becomes very, very high. So, all this you will learn in this course. Power does not change with gear ratio, that is the important thing. Gear multiplies torque, divides the RPM, the speed. And if there are 3 or 4 gear ratio, you can multiply more, reduce RPM also more, or you multiply less and reduce RPM less. Power does not change. Power change is different. Power change is the current. To sum up, vehicle performance parameter is vehicle performance is characterized by torque and speed. Torque is in newtons, speed is in kilometer per hour, and power. Power is a watts, multiplication of torque and speed. It is not an independent parameter. Determined by IC engine or electric vehicle motor. Gears can multiply torque at the expense of speed or vice versa. There is one more thing that is often confused between what I call nominal or normal and peak values. Nominal values of torque, speed and power. Nominal values is something that you can use on a continuous basis. Sometimes say cruising, you do not have to worry anything. That is what the motor and controller has been designed for. Peak is we can for a short period of time can push up the power, speed, torque, power for a short period of time and then bring it to the normal. Now, this is again something very interesting. I also did not understand it in the beginning. I have a 5 kilowatt motor, maximum power is 5 kilowatt. But a short period of time, the motor per se doesn't get limited by 5 kilowatt. It is a controller which gets limited. I can push the controller to give you 8 kilowatt power. But what will happen when I do the 8 kilowatt power? It will start getting heated up. It is a thermal design of motor and controller which limits the power. 5 kilowatt, it can run for continuously. Whatever heat it generates, it can dissipate, the temperature will be constant. If instead of 5 kilowatt, I push it to 8 kilowatt, I can do this. I can do it for few seconds, maybe 10 seconds. After that, heating will start going up. If I continue it, it will blow the motor or impact blow up the controller or impact the motor. For example, motor may have magnets which may get demagnetized. So, when you run things at thermal equilibrium, you call it a nominal or normal values or continuous values. Peak you can always do. You can do this for motor controller, you can do it for battery. You will find battery is normally designed to give so much of current or so much of power. You can for a short period of time increase it. Generally, whenever you do it, increase, you are taking more out of it. it starts getting heated up. You will not be able to dissipate enough heat and you will land up into trouble. It may blow. So, for a short period of time you go and then bring it so that it has enough time to cool. Very similar to, mind is quite capable of functioning at a normal speed. You are doing this, and for a short time you can concentrate and really do much more application of mind. But you can do it for a short time. If you do it for a longer time, you will get a headache. Headache is pushing you back, saying, sorry, you are overusing your mind. Equivalent thing is in a motor controller or battery, it will start heating up. Thermal equilibrium will go for a toss. Slow down. That's an important thing, and this is not something that is well understood again by engineers. Motors and controllers, but for thermal, could actually operate on much higher power. But thermal limits it, particularly for motor, even for controller. So, this is 1.2. We will also worry about specifications of motors and controller. We will have to derive from vehicle drive requirement. You can't have motor and controller speed cannot be on its own. You first figure out what vehicle are you going to drive, under what road conditions are you going to drive, what gradient are you going to drive, what speed are you going to drive, what is the torque that is required. Figure out the vehicle torque, vehicle speed, vehicle gradient, figure out what gear ratio are you going to use, and then derive the motor and controller specification. This is important. Motor specification to derive from what is called torque and speed curve. What torque, what speed? Torque, speed curve, nominal torque and speed plus peak torque and speed. Based on that, you derive the motor specification. Power, nominal power, heat removed so that temperature settles, as well as peak power for a short 10 to 15 second, torque into speed by 9.5. Motor can be driven to higher power as long as heating does not become a problem. So, thermal, some components including magnets impacted by high temperature. Almost all the electronic components can get impacted by high temperature. Your MOSFETs can blow. The mechanical you have to worry about, your thermal you have to worry about all the time. Mechanical, is there going to be larger vibration? If you go for higher speed, size will go up, weight will go up, all those things. So, there is a thermal and mechanical constraint that says, well, you cannot do more than that. Remember that I talked to you, if you want the same power, voltage is lower, you require larger current. Voltage is higher, you require less current. The current dissipated is always I square R. If you have large current and you square it and multiply it by R, huge heat is generated. If you have smaller current, voltage is higher, smaller current, I square R is less. Your current, you can handle things more. Now, that is just a way of explaining it. Of course, the current then is used in all kinds of manner, and you will learn all of it later on. Now, with this, I think time has come for your first assignment, a very simple assignment. You need to do this assignment in time and submit. This assignment carries marks. Some assignments will be very straightforward. If you have gone through the lectures, you can almost orally answer. Some will be somewhat tough. I will start with the first assignment. Assume a vehicle with wheel radius of 0.3 meters. Convert speeds of 1000 RPM into kilometer per hour and meter per second. Convert speed of 2 meter per second into kilometer per hour and RPM. Convert 80 kilometer per hour into meter per second and RPM. Straightforward. I had done this, given you the formula. Just do that. Get used to that. Those 2-3 equations that I did, very straightforward, school level, don't miss that.